Go.
Good afternoon. Today we'll be looking at some challenging questions, and Mr. Underwood will lead us through.
Beautiful. Thank you, Christian. All right. Now, okay, so in this one, we've got it says find an equation that's parallel. So what does parallel mean? It means that we have the same gradient. Okay, so of course 2 points, same gradient means that they're going to be parallel. All right, so I've just drawn 2 parallel lines there. So let's call that equation y is equal to 6x plus c. That should be your first step. Don't write anything else. And of course, we want to find what c is. Can you see, if I was to have, let's just say 2 parallel lines, they're going to be the same gradient, but they're going to have different y-intercepts. Okay, this one here has a y-intercept of 0. So c would be 0. So, but you can see there we've got a point 315. So what do? We substitute it in. So when x equals, you don't have to write this in, but I guess what we're doing is, the thought process is that when x equals 3, y is equal to 15. Now let's substitute that in. We've got 15 where y is, and 6 times 3, I'm just putting that in a bracket, plus c. Let's evaluate that now. 15 is equal to 18 plus c, and subtracting 18 from both sides gives us negative 3. And now we're done. By piecing together or knowing that 2 parallel lines have the same gradient, we've got our equation is y equals 6x minus 3. And you could underline it, you could put a highlighter through it. As long as I can see one answer, just be careful. If you're doing a test and you write 2 different answers, I can't give you an answer mark. Okay, there are students who tend to do that. Now, I would say that finding the equation of a parallel line would be far easier because we already have given the gradient. Now, just remember, when you go back, and I'm going to go and show you page 2, your formula sheet is going to look something like this. This is exactly what your formula sheet is. You open up your test and you'll see this. Now, I had a lot of students in the other class ask me, what is this? If you've revised thoroughly and you practice many questions, if I have 2 lines which are perpendicular, their gradients multiply to give -1. It's right there for you, okay? So, but if you're spending too long on a formula sheet, what's going to happen? You're going to run out of time for the test. If your skills are in sort of, a little bit on the low side, or maybe you haven't practiced enough, you might find yourself struggling for time. So what I'm suggesting is if there's something that you know that you really can't do, you have to move on because there's going to be many marks where you can actually get. What I find is when students come into year 10 into senior years, they dwell on questions too long, questions that they're never going to get in a million years because maybe they just don't have that knowledge. Maybe they'll get it after the test. My advice to you is simply just move on. Okay, so I'm going to go back to, what was it, page 15, wasn't it? Sorry, challenging skills. All right, now for the second one, it says perpendicular. Now, what we're going to do is to sort of keep with this rule, I'm going to call this y1. This is what we've got, y1. Now, what is the gradient of my y1 here? What's the gradient? It is 2. Thank you. So we've got m1 is equal to 2. Now, we've got to find the equation of y2, and y2 is perpendicular. Now, I'm going to call that m2x, which we don't know what m2 is. But we do know that the piece of the puzzle is that we've told that this line here and this line here are perpendicular, which means that they're gradients. Absolutely, very good. So, Lucas, we've got 2, and in other words, what we've got is I've got my gradient 1 here, and I multiply it by something, and that's going to give me -1. Now, you can do quite a few things. So a really good trick is you can see there, if the 2 gradients I'm looking at, this one's 2, what we can do as a bit of a shortcut is we can flip these 2 around. Okay, so the 2 over here, would become a 2 over there, and the 1 would become up top, and it's the opposite sign. Two lines have to have opposite gradients if they're perpendicular. Can you see there? This one here is a positive line. This is a positive line, and this one has to be a negative line. So if you can get that gradient really fast, then and realize that the gradient we want is this -1/2 here. How else could we do it algebraically? Well, we could say that m1 times m2 is -1. We know what m1 is. 2 times m2 is -1, is equal to -1. And can you see there that I've got 2 times m2? Let's divide both sides by m2, by 2. Yeah, well, we can go through those questions in a moment, okay? All right, so divide both sides by 2, I got -1/2. Can you see there that just rearranging and finding m2, that is the same thing. Or we could do it this way, where we can simply just flip that 2 and the 1 and use the opposite side. Now that we've got this though, we've got y2 is equal to -1/2x. That's the hardest part, plus c. But you can see there that we've got a point on that line, and we're going to substitute that in to find the missing part. Okay, so when x is equal to 2, y is equal to -4. That's right. So let's substitute that in, and we've just got to go ahead and find out what c is. So in this case, what's going to happen to these 2's? They're going to cancel out, so we've got -1 over there, and if I add 1 to both sides, that's going to give me c is equal to -3, just like the other one. So therefore, state what the equation is. We've found the gradient, which is -1/2. Don't forget the x. A lot of people forget the x. You would lose marks for that. And then, of course, our c, which is -3, and that's the answer. Okay, so finding the equation of a line, parallel, perpendicular, that would be one of your sort of more, I guess, challenging skills. We'll do another one which is a little bit on the harder side as well. Okay, maybe just as far as in terms of the numbers. Okay, now with this one, you might not be given a graph, but can you see here that what I want you to do when you go to your page 2 of your formula sheet, I would like you to label these x1 and x1 with a y1. That's the point on the left. And the point on the right is x2, y2. So we've got to find the equation of a line. Now, you don't have to write this out, but we know that finding the equation of a line is we've got to find an m and we've got to find a c. Well, because you've got the 2 points, thankfully here we could almost go, well, what's this rise and run? Well, what I've said all along is that our gradient is our rise, which is the same as y2 minus y1, the difference in those coordinates, over x2 minus x1. Doing that will save you time. If you do it the long way and draw a triangle and try to work out what the rise is and what the run is, you're only wasting your time. Okay, you're not necessarily going to be given a graph. You could just be given 2 points. So let's do that. Wherever the y, so y2 is 7 and y1 is 11. 7 minus 11. And we know, wouldn't you agree that just by looking at this graph, we know our answer is going to be negative. It's going to be a negative slope. x2 minus x1 is 6 minus 3. So you can see there that 7 minus 11 is, I feel like a Slurpee now, is minus 4. And 6 minus 3 is 3. So what that means is that we found our gradient, and once again, plus c. Let's go ahead and find c. How do we find c? Substitute a point. You don't have to necessarily, well, it'd be nice when x is equal to 6, y is equal to 7, but if you went straight to throwing in 6 and 7 into this, you're not going to have to write this step here, but I'm just explaining to you the process, okay? So wherever there's a y, I'm going to replace it with 7, and wherever there's an x, I'm going to replace that with 3, like so. Now, of course, you could go ahead and multiply 6 times 4, which is 24. You divide by 3, which is 8. Or we could even, if you wanted to, you could cancel this out. 3 goes into 6. 2 times. And of course, that's going to be minus 4 times 2 plus c, multiplying across, which is negative 7 is equal to negative 8 plus c. Okay, so now we just add 8 to both sides. So therefore, c is equal to 15, which means that our equation is y is equal to minus 4/3 x plus c, but we just found c, didn't we? Is 15. All right, so first of all, can you see there that it's the same thing? We've got to first of all find the in this case, find the gradient. Using this rule would be nice, because if you're drawing triangles and doing it the long way, the old rise over runway, well, this is the rise. y2 minus y1 is the rise, and x2 minus x1 is the run. And it's certainly a shortcut as opposed to probably how we do. Some of us are doing it. We've got to be mindful of the time. Now, I would consider this to be probably the most challenging question if I asked you of skills for this entire unit, this one. So just a forewarning, I would prefer to go through it for 10 minutes with you after we go through this. I'm going to try and go through the steps. All right. Now, first of all, straight off your formula sheets, you go to page 2 of your test or of your revision sheet. We're finding the distance. So D for distance, there's your formula on there. And the distance is basically a shortcut of Pythagoras' theorem. Okay, a squared plus b squared is equal to c squared, is it not? Now, how do I cancel out the c squared? Because this is going to help us with this problem. I take the square root of both. If I take the square root of this side, I have to take the square root of the right-hand side. What's the square root of c squared? C. So c is equal to the square root of a squared plus b squared. That is exactly, in this case though, this c is the distance. Okay, so in other words, if I've got some sort of 2 points here, and we are actually finding that distance here, we're going to call, I guess, D. All right. Now, D, let's write the formula out. It's x2 minus x1, x1, the difference between the 2 points, and that's squared. Okay, you could take it straight off your formula sheet, and that could be your first step, is writing out what the formula is. y2 minus y1 squared. Okay? Doesn't matter. You're adding two things and you're squaring them, but it's the difference. Now, let's first of all, let's just on this here, it says the distance between 1a, comma a, we don't know what a is, and 3, 7. So what we're gonna do is, this is the point to the left, isn't it? Because that's 1 and that's 3. So clearly that's going to be a point to the left. So what we're gonna do is the point to the left, we're gonna call this x1. You need to get in this habit. y1. And the other point is x2, y2. The only difference with this is you don't have nice numbers. Well, you do, but there's an A there. So that's where it can get a little bit tricky. Otherwise, it's just pretty stock standard. Let's throw those in. So our distance, let's write that, is root 13. Okay, the square root of 13. And on the left-hand side, the right-hand side, x2 is equal to 3. So it's 3, and x1 is equal to 1. So that's 3 minus 1 in brackets squared. Okay, and by the way, this is on page 29 of your notes, and we went through it once on the whiteboard. So this one is in your notes. So feel free to sort of go through this. I can actually email it to you as well if you sort of missed out for today. But quite a few of you might have already tried this in your notes. We certainly tried it on the whiteboard. Now, the second part, this is the tricky part, is y2 is 7, but y1 is what? Is a. So it's 7 subtract a squared. Okay, now just follow me for the time being. How do I cancel out the square roots on both sides? What would I have to do? We square them. So if I square root 13 times root 13 is simply just 13. Okay, we're squaring both sides. So I'm squaring this side now, and I'm actually squaring this side out. That just essentially just cancels out the square root signs. If you think about it, everything inside the square root on the left-hand side must equal the right-hand side. So let's ignore those square roots now, and we've got 13 is equal to, let's do this, 3 minus 1 squared is the same as 2 squared, and then I've got plus 7 minus a squared. No, we'll get to that in a second. Okay, we've got to find out what a is. What we're going to do though is I'm going to get that 2 squared is 4, isn't it? So we've got 4 plus 7 minus a squared. I'll show you a little trick in a moment to solve this, because now let's subtract 4 from both sides, which gives us 9 is equal to 7 minus a squared. Now let me just pause this video, because I know that this is something that usually is I need to really. All right, so we discussed that over here that there's two methods of doing this. There's the guess and check, okay, which of course we sort of can do without sort of any algebra. What that was is we know that there's two solutions to, if I was to take the square root of 9, or minus 3 squared is 9, and 3 squared is also 9. So I guess what we discussed is, how does 7 minus something squared was to give us 9? Well, that something was 4. 7 minus 4 squared, all squared, is 3 squared, which is equal to 9. So therefore, one answer is a equals 4. But the other way we also discussed, sort of off camera, shall we say, is we said 7 minus 10 and then with a squared was also equal to 9. Okay, so therefore that would be the same as negative 3 squared is equal to 9. So therefore A is also equal to 10. Now I will accept, if you guessed and checked in this, especially this early in the year, we would give you your marks. I'm looking for this is an answer mark out of 3. This is an answer mark out of 3. And of course I want to see, a method, a viable method. The other way of doing it, and please note that this will be the first time, so let's ask those questions and go through it and explain further. But I'm getting this line over here, and what we're going to do is I've got 9 is equal to 7 minus a squared. Now I want to solve and find what a is. So if I take the square root of both sides, we need to consider there needs to be a positive and a negative solution. The square root effectively cancels out that squared. So on the right-hand side, I've got 7 minus a, but in actual effect, we've got the square root of 9 is 3, but as we discussed, there's a positive solution and a negative solution. That's where we can write as plus minus 3. Now, to be honest, because this is both signs, I'm going to show you a little shortcut. I want to get, if I want to get a on the other side, we could add a. Okay, let's add a. And if I add a, that gives me a is equal to, or a plus minus 3 is equal to 7. It doesn't matter, we've got two signs over there. So let's just get it over here. All right, it's actually the same thing because there's two signs. We'll be adding 3, we'll be subtracting 3 to both sides. So really that sign can go over the other side. So if I cancel that out, 7 plus 3, 10. 7 minus 3 is 7. So 7 plus 3 is 10. 7 minus 3 is 4. That's an algebraic way as opposed to the old guess and check way. All right. Now, I'm going to pause this. I would love for you to, so I'm going to hit the pause button. What I'd love you to do is, this question here involves quite a few different steps. So we're going to have a go at this. So just quickly, we've skipped a few steps. What we're saying is we've got y1 is perpendicular to y2. Now, what we've got to find is, we've been told what m1 is, the gradient. That's 4/3. So my suggestion is write out what you know, please. Then you can, like a lot of students, they just don't write anything. They don't make a start. They don't get any marks. So what we've got to do is find M2. Now, of course, you could do that algebraically. You can multiply both sides by 3 and divide by 4. But I guess once the trick is, if two lines are perpendicular and we've got a fraction, or even if it was 2, 2 is the same as 2 over 1. I can flip these around and make that 2 a fraction as 2 over 1. What that means is if I was trying to find what's perpendicular to a gradient with 2x, that would be, let's flip these around, 1, 2, and change the sign. So let's do the same thing over here. Let's flip these around. Just one sec. We've got to flip those around, okay, as in from here for our second, and the opposite sign, because as you can see, two lines can only be perpendicular. Two lines can only be perpendicular if they have opposite sign gradients, one a positive and one a negative. Never going to happen. They're never going to be perpendicular. So what we have is here, y is equal to minus 4/3 x, and you guessed it, plus c. We've got a point, so let's substitute that point in. When x is equal to minus 4, y is equal to minus 2. So we've got this. That's going to be times by 4 plus c. What happens to the 4s?
Cancel.
They cancel. And then I've got to add 3 to both sides. So now, by the way, that's a negative 4. So be very careful what happens to that. Very good. So we've got minus 2 is equal to positive 3 plus c. C is equal to negative 5. All right, everyone. That's good.